Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, we're going to extend the idea of bivariate case from discrete to continuous. Okay, so here we've got x and y, which are continuous random variables. Then what we have over here, this mathematical notation here, we will call it the joint probability density function of x and y. Now remember the simplest case which you have seen in the previous video, where you have one random variable x and x here is a continuous random variable. So here from this notation we can find what is the probability density function for x, and it is defined as fx. So notice that now what we are having right here is two random variables that are continuous. So therefore when we are dealing with x and y, continuous random variables, then our fxy, so we're going to call it x and y, we're just extending this expression here to include another random variable y basically, and we are going to call it joint because they happen together. So x and y happening together, so we call it joint PDF. And because of that, we are going to deal with double integral. So we call that, in the case of one single variable, we only have to integrate the function once. So we've got some integration process going on here, and we're doing it one time. But here we are dealing with a double integral. So we're going to integrate this joint probability density function with respect to x, and then we're going to do it one more time with respect to y. Actually it can go the other way around. Doesn't matter if we do it with respect to x first and then y, or you want to do it dy dx, that is also fine really. Okay, similar to the ideas given in the discrete case or continuous case for one single variable, you can see that in order for this item here, what is this? This is the joint probability density function. In order for it to be a joint probability density function, the value of it must be greater than or equal to 0 for any range of x and y between negative infinity and infinity. And if you consider integrating it twice, you integrate this function twice with respect to x and y, and the limits given here is from the defined range, so the answer should be equal to 1. Okay, now we're going to look at a simple example here. The answer is already given right at the bottom. It says here, given the joint probability density function, so this is the joint PDF defined as such, find the probability of x and y in region A. So A is the region defined as x between 0 and a half and y between 1 and 2. Okay, so we're going to find what's the probability of our two random variables being in that defined region here. Okay, so what we have to do is we have to integrate this joint probability density function twice. First, we can do it with respect to x or y. Okay, so what we're going to do next is, like I told you earlier, this one, you can either do it dx or dy, or you can do it the other way around, dy dx, doesn't matter really. Okay, so let's say for this one, we just do it with in this order, dy and dx. Okay, you at home can try and do it according to for example dx dy, and what I'm going to show you right now is I'm just going to switch this the other way around. So I'm going to do it dy dx. Okay, right. Okay, so here we've got this function here. This is 3 over 5 x y plus x, and I'm going to do it dy dx. Okay, first with respect to y, and then I'm going to do it once again with respect to x. Therefore, the inner limit here must be related to y. So for this one, y is between 1 and 2. So this is the inner integral. We're going to do that one first. And after you have got the result, you're going to do one more time with respect to x. So x is on the outside. So here is the limit associated with x. So the limit here is going to be from 0 to 1 over 2. Okay. And we can see clearly that 3 over 5 here is a constant, so you can put it outside. Okay, we can just not consider it for the time being, so we're going to put that outside. So 3 over 5, here we've got 1 over 2, 0, 2, 1, and I'm just going to expand this expression here. So I've got xy plus x squared dy dx. Okay. Next, what I'm going to do is I'm going to integrate this part. Okay, we're going to integrate this part with respect to y. Okay, so the result is going to be 3 over 5, 1 over 2, 0. So here, the process of integrating this, so xy, x can be considered as a constant. So therefore, the result of this is going to be xy squared over 2. Plus, again, x here is a constant, so if you integrate this, you will get x squared y. So that's the result, and you can consider the limits from 1 and 2. Okay. Right, next what we're going to do is we're going to substitute all these values here and do the process accordingly. Oops, sorry. So let me just... Okay, so here what we're going to do is we're going to write down the results that we've got, half and 0. And right here we're going to substitute 2 into y. So we've got x 4 over 2, yeah, plus 2x squared. So that's the first one. Minus, so we have x over 2. Okay, you substitute 1 into y, so that is x over 2 plus x squared. Yeah, so this is dy. Now we're just going to simplify the results that we've got here. Okay, the results here can be simplified into 3 over 5, half and 0. So here we have 2x. This one is 2x squared. This is negative x over 2 minus x squared dy. Okay, and I think you can also see that this part here can also be simplified as we can write it in terms of 2x minus x over 2 is going to be equal to 3 over 2x. Okay, you consider this and this. And then 2x squared minus x squared, it's going to be plus x squared. So itu adalah, sorry, cakap dalam BM pula. So that is the simplified version of the result that you get right here. Okay, okay, bye. Alamak, sorry. Okay, so here we have 3 over 5, 1 over 2, 0, and we're going to write down this simplified result that we have. So we've got 3 over 2x plus x squared dy. Sorry, dy pula. Oh, God. So here is actually dx. We're already done with dy. Okay, sorry, my mistake. This is actually dx, yeah? This is also dx, and this is dx, okay? Right now, we are going to continue integrate this function, and you will get the result is going to be, so 3 over 2x is going to be 3 over 2 x squared over 2, yeah? This one is going to be, the result is going to be x cubed over 3. And here are the limits, 1 over 2 and 0. Okay, right, let me just erase this part because I'm running out of space. Okay, now our job is very simple really. We're just going to substitute the values of x into the result that we have. So we're going to substitute 1 over 2 into x, okay, into this, and then minus. So if you substitute 0 into this, all this become 0 really, so we don't need to minus with anything, we just minus 0. Well, therefore the result can be written as such. So 3 over 2, so x squared is 1 over 4, so this is 1 over 4 over 2. Yep, this one is going to be 1 over 8. Yeah, so this is plus 1 over 8, this is over 3. And no need to subtract, because if you substitute 0 into this, it becomes 0. And from here you can punch in your calculator or whatever, and you will get that the answer is going to be equal to 0.1375, or if you want to express it in terms of a fraction, it's going to be 11 over 80. Okay. Alright, I think that's all for now. Thank you very much for watching, and I'll see you in the next video with more examples related to bivariate continuous case.